Hello, everyone. My name is Sławomir Jasek. I've been dealing with InfoSec for quite some time now, and recently I provide also smart lock-picking trainings about insecurity of modern smart locks, home automation, and access control systems. And today, I'd like to debunk some common myth that hacking RFID requires some elite knowledge or advanced, expensive hardware. And I think that despite the fact it's pretty simple and pretty well documented all over the internet, it's somehow beyond the reach of most of us. So today I'd like to offer you a red pill that will unravel at least a little bit of this mystery and hopefully encourage you to research this topic further or at least raise some awareness, which is always the first step to mitigate the risk. I will try to squeeze as much as possible practical information. So for some slides, it might feel that it's too much information to parse. But don't worry, the slides will be available for download, and I will definitely tweet about it. So I prepared it as a future reference for you for your own practicing. So we'll cover most common systems, UID-based access control. I will walk you through cracking MIFARE Classic, and we'll decode the data stored on the card, including one hotel system that I cracked. And I've created Mastercard that unlocks all the doors, but unfortunately, I can't tell you all the technical details about it because the vendor doesn't plan to patch it. And I will also give you a small sneak peek about my recent research regarding mobile access control systems that unlock the door using NFC of your smartphone. So. Just an obligatory disclaimer, I'm sure no one of you wants to get to the jail, so do not attempt to break the law. I believe you are pretty aware that that NFC, RFID is everywhere. It's used for access control, bus, train tickets, e-wallets, loyalty cards, and so on, contactless payments, and even a tiny tooth-mounted sensors that can track what you eat. But where do we start with these cards? Well, first, you need to know that there are lots of various different types of cards. And most commonly, they are divided into several types based on the frequency on which they work. So we have so-called low-frequency cards. They are quite often referred to as RFID. For example, EM tags are very common. We have the high-frequency cards, like MIFARE. We also have lots of different systems working on different technologies, but we will not focus on them today. And how do you recognize the card type? Well, if you just take a look at it, it won't tell you much, because this may be low-frequency or high-frequency cards. So just by the look at it, you usually won't be able to tell what type of card it is. Actually, the coil itself can be pretty small. It can be even implanted in the hand. By the way, Patrick is a very nice guy, so if you are interested in this topic, he will explain all of this to you. Unfortunately, we can't use implants for now as bus tickets, because especially if your name is Miao Ludo Disco Gamma Miao Miao, who was fined despite having perfectly valid bus ticket, but built into his hand. But going back to how can you actually recognize the card type, well, the most simple thing you can do is just to use your mobile phone that operates on the high frequency. And there are free mobile applications that I will reference to you a little bit later. And if your mobile phone just simply recognizes this card, it means it will tell you a little bit about it. But if not, it's probably the low frequency. Let's start with access control. The simplest access control systems just store UID on the card. And the UID is just a few bytes. Sometimes it's random. It's read-only, and it's freely accessible to read. So anyone who is in close range to the card can read it. And the reader just checks for the registered UID, whether it's valid or not, and gives you access. So the whole security of this is based on the fact that the manufacturer sets this UID on the tag, and it cannot be altered because no one else knows how to make such tag. And guess what happened next? Well, of course we have tags that can change this UID, and depending on the technology, you can use T577 or the magic UID for MIFARE, and you can buy them for like 30 cents at this moment. But if you actually want just to clone a card, a UID, you can just simply buy this $9 RFID card cloner, and it will do the job. You just read the original card, you press it against the card to duplicate, or you can use also other form factor, and it's done. Basically it. So if you compare this to a typical most common USB NFC reader that just allows you to read the tags, not clone them, it looks like a little bit overpriced. But fortunately, we have Live NFC. It's an open source library that exploits hidden RAW mode of this chip. And this RAW mode allows us to do a lot of interesting things, like emulating cards, cracking them, cloning, and so on. And the good thing is that you actually don't need to buy this one, the USB one. You can just simply buy PN532 bare module that comes starting for $4. Well, actually, the cheapest ones have usually poor antennas, but oh, this is how it looks like. But it usually works good enough. So we have prepared, we have selected the ones that work good enough, and have created some called NFC Research Toolkit that you can win. And I have several of them for you today. It allows us to crack MIFARE, clone cards, and so on. And we've prepared several challenges also. So I will start with the first demo. I have a simple access control system that just by, when I press a valid card, it unlocks my magic box. So I will just place this card on this board, hopefully. Okay. So I will just list it and have the, I don't see it from here, but I have a valid UID. And then, oh, here it is. Okay. Then I will just take this magic card and place it on this reader again. I need to stop. I will just set the UID. Okay. 5. And it should, now this magic card should unlock this. And it works. It's just that simple. And it works for a lot of access control systems. Like, I've seen it in banks and offices and apartments and so on. So you might be surprised in how many buildings it works. But we can actually detect such cards because they rely on a magic special commands. So there are systems that can contaminate such malicious users and detect such cards and just discard them. So I have a first question for you, and I have a reward for the answer. What's the Chinese answer to this problem? So we have magic cards, and they are recognized by the systems. So what an attacker can do? Yep. Yeah, well, you're close. I mean, there are cards that, first, there were cards that created this, that allow you to change without this magic command. But then there came cards with one-time write. So I guess I can accept this answer. Thanks. So now we have cards that allow you to write this UID only once. So next time, it's not, you cannot tell it whether it's original or not. And by the way, if you use 7-byte UID, there are also, of course, 7-byte magic cards. You can also emulate a card. You can use, for example, this small device that can emulate up to 8 cards, I suppose. And there is also a smaller one at $45 with interesting new feature that I will show you a little bit later. But if you also want to emulate the EM low-frequency tags, you can just buy $2 EM4095 and connect it to Arduino, or use, for example, I haven't taken it, ready tools for that. And you can also use Proxmark. Proxmark is a most renowned access control I don't know, RFID, sorry, RFID research thing, hardware. And it comes a little bit more expensive, but gives you much more possibilities. There are cheaper Proxmarks, like I have here this Chinese one. You can get it a little bit cheaper, but it comes with poorer antenna performance. But in most cases, it works good enough. But if you're interested in buying one, I would recommend waiting for this Kickstarter. They will start selling in July. And probably it will be the most interesting, the better one. I hope so. If you would like to emulate the card, you could, for example, brute force UID to get entrance to a restricted area. But in many technologies, it doesn't make a lot of sense because the UIDs are random. But in some, it might be useful. So we can use Proxmark, for example, to brute force sequential UIDs. You can also use smartphone. In the smartphone, you can just simply read the UID. There are free mobile applications for that. And just give you this 4-byte UID number. You can also emulate it. And this is unfortunately not really easy, because you probably know that you can emulate cards using your smartphone, but these are different kinds of cards. The access control based on UID works on a different level, and these UIDs are by design random. So I have managed to manipulate this process in Android. So I can set any UID, specific one, and unlock unlock the access control system, just by simply editing the specific files in Android. You need root for this, but then you can probably use your phone to your access control system. That depends on the chip. Just edit these config files in a proper way. And I was thinking about creating mobile applications for that, but someone else figured it out in the meantime. So there is a mobile NFC card emulator application, and it just does that. If you'd like to play with it, it will be available at our booth later. So you just scan for application and for UID, and then you can emulate it simply. For iPhone, there is also an option for that. You can use iPhone if you have jailbreak, and I will just start the TAC emulation, and it unlocks the system. So it's just simple as that. So if you'd like to play with it, like I mentioned, it will be available later. But do you think you can clone a card from a picture? Has anyone seen such small numbers printed on the card somewhere? How do you think what it is? Well, of course it's UID, and who's gonna tell me how to decode it? Any ideas? I have another reward. Yes, exactly, it's decimal, you just convert it to hex. It's you? Thanks. In this case, you just convert it to hex. Sometimes it might be reversed. Sometimes they use 3 bytes instead of 4 bytes, but it's usually pretty simple. It might get a little bit complicated for other tags, but you just need to use specific digits of hex to convert it to decimal. But you've got online calculators and Excel sheets for that. So it is possible in many cases to clone a card based on the picture of it if you have these numbers just printed on it. And this knowledge doesn't seem to be very common among users. So I don't think that hiding access card is encouraged practice. But we still haven't taught them to actually do not put stickers with PIN numbers on the cards, so I guess it will take some time. By the way, if you just want to enter the building, you don't need to have a valid card. You just have any card, and the next person will allow you, will let you in. So, well, just users. We know that in the simple systems, this UID is just accessible for all, and it's not protected. So out of this need, there came new cards that allow you to, that store this UID in a protected way. So this was more secure, encrypted, and so on. Only valid reader can read this tag because it has the matching key. And it became quite popular, and the system was implemented in many places. And can anyone tell me, is there any problem with this? Like, I will quote the guy who did it. You can break a single reader once, and then you can enter anywhere. So they actually did it. I'm sorry, I don't have enough time to explain this, but this was a brilliant hack. They bypassed memory access protections in the reader. And they they didn't reveal the key itself, but only the way to dig it out of the reader. And well, it found its way into the internet. And by the way, it's not the exact key needed, and it's just the first key. But I'm sorry, I won't reveal you more about this. This forced the manufacturer to create more secure ones, which have individual keys per installation. By the way, if you would like to know a little bit about memory access, readout protections, and bypassing it in microcontrollers, I will do a short live demo of it at our booth today at 3:15 and tomorrow also. What happens between the reader and the door? Typically, it is connected to some access control backend system, and in most cases, it uses so-called weekend. It uses just 3 wires, and this is data 0, data 1, and ground. And the transmission is pretty simple. So you have 5 volts, and when it drops down to 0, it means 0 on data 0, and it means 1 on data 1. So it's pretty simple, and just the clear text bytes of the tag UID are transmitted along with parity bits. So even if you have secured the communication between the reader and the card is impossible to clone, for example, it's quite often that what happens after the reader is clear text. And the readers are quite often easily detachable. So like the simplest ones you can just unscrew and have access to the internals. So I think you would know what happened next. Well, we do have several such small plugs. Let's call it, it's this size, so you can easily attach it at the back of the reader. And this one just collects all the UIDs of all the cards, and then you can connect to it using Bluetooth. To this one, to this one, you can connect using Wi-Fi. So it's just its own access point, and you can just download all the collected credentials. So for that, I would advise to use tamper protection, because most more advanced readers have tamper protection wires, but unfortunately, in many cases, they are not connected. And of course, multiple layers of security, breach detection, and so on. There is OSDP that encrypts this connection, but it's not very common. So some cards, beside the UID, also have a data, like MIFARE, for example. And the simplest MIFARE is the MIFARE Ultralight. It doesn't have any security. It just stores the data. And in order to read it, you can use just a free mobile application, like MIFARE++ Ultralight. And I'll try to demo it. OK. So I have this mobile phone. I'll just take example Ultralight hotel card and use the MIFARE ++ card, and it's just the content of the card. It's scrambled. We'll get to this, how to decode it later. But if you just want to clone this card, you just take a magic card and press right and put the card, and it's done. So the card is cloned now, and it works in lots of hotels. It's that simple. You just need to have a special tag that allows you to write this restricted areas, this UID of the card using Android. But these tags are available. There are a little bit more secure ultralight cards like EV1 that have ECC authenticity check, but you can have more advanced magic key tags to emulate them. So I would advise to use ultralight C, which is properly encrypted. So let's move to the MIFARE Classic. It's probably the most widely used system. And it's everywhere. There are city cards, access control, student IDs, memberships, internal payments, and so on and so on. It stores the data in sectors, and each sector has several blocks. And you have access keys to specific sector. So the thing is that lots of cards use just very simple keys. So you can just simply brute force them or use the default ones. You can use, again, free mobile application for that. And I will try to show it. Okay. Oh, yeah. So I will just take a simple MIFARE card. I will try to read it. And it has just a dictionary of known keys. So now I have all the card content. If I only know the proper keys. I would just make a simple graph how to crack MIFARE Classic. If you have all, you can just try the default and leaked keys. So then, if you succeeded, then it's well done. It may take a few seconds, for example. But if you don't have all the keys, and if you have at least one, and it's quite often that some sectors are left with the default keys, you perform so-called nested attack. I will a little bit fast forward here because it will be just for the reference. You can do this nested attack using even this cheapest libNFC. It takes like several minutes. And if you'd like to do it using Proxmark, it takes about 1, maybe 2 seconds per key. So it's not really time consuming. So again, but if the card is properly secured, so it doesn't have any keys left in default, then you can use another attack that works a little bit slower. Using this hardware, it can take up to an hour, but using Proxmark, it takes about 30 seconds. And if you have at least one key, you can proceed with the other attack. So these attacks were just a simple implementation flows, like problems with random number generator or side channel. So it was quite easy for the vendor to patch it by releasing special improved hardened cards. So we have MIFARE Classic EV1. It fixes the export vectors, and these attacks do not work anymore. But we have another attack, which came out in 2015, and you can also use this hardware for this attack. And there is a tool that automates this very easily. It's called My Lazy Cracker. And you can perform this hard nested attack also using Proxmark if you want. But what if you don't have any keys on the hardened card? Well, then you can still recover the key, but by online attack, but you need to go to the reader, and you need special hardware like this, for example. It's $45 hardware. You just program it using GUI to collect the keys, let's call it, to sniff the communication, and then come back to your laptop and crack the key. Okay. So, final NXP recommendation from 2015 is do not use the MyFair Classic. Well, of course, it's not easy to upgrade such systems. So they use some workarounds that make the attack more difficult, like enforce you to buy this and go to the reader. And, well, these are like workarounds that do not completely fix the problem. So you should migrate to more secure chips, like this Fire, for example. But it's also important to implement them correctly, because I have seen systems that use this Fire, but check only for the UID. Of course, it depends on the implementation. Okay, so we know how to get access to the card content, but as you probably noticed, the example hotel card I showed you was somehow encoded. It's quite often encoded using this individual UID, so it's diversified fed cards, so the same data is stored in a different way on a different card. So let's take a look at two cards from the same room, for the same room and the same hotel. And the red ones are differences, and they are pretty different. Well, even if we discard this card UID that's in the beginning, I suppose at the end is some kind of checksum. So in the middle we have encoded access card data, and it's pretty different, but do you notice anything suspicious about it? How can we decode it? Yeah, the repeating 7E or 8.2, like, yeah, thanks. And the question is, how can we decode it? Like, yes? Yeah, probably. Yeah, we don't know the key. Maybe. But how do we reveal the clear text? Yeah? XOR. You said XOR, right? Sorry, that wasn't me. Yeah, XOR is a good answer, so thanks for this. If we just XOR this by 7E, well, we can assume that probably over there are just zeros. So we will just XOR this by 7E, and we'll get the, let's say, the clear text version. Now if we compare the two rooms, the difference is much smaller. So we have decoded this magic encryption, let's call it encoding algorithm. So we could proceed with different cards to the different hotels and different rooms and so on. This guy wasn't as much positive like these guys that followed this. This was the initial step in the research, and they finally made it. Thanks, among others, to the fact that they had lots of cards, thanks to hundreds of travels of a colleague. And they got the hotel software from FTP, and they also got the serial number that was in the software manual. So they were able to create their own Mastercard. But it didn't work in real hotel because all the hotels have individual keys. So they got Mastercard from a friend hotel and just tried to fuzz it. What's the minimal bytes required for this to work? So it turned out that just by having any guest card and a few brute force, they could create Mastercard, and they used Proxmark for this. So it's about how it worked. But I have for you another hotel that I have reversed and created Mastercard for it using similar techniques. So I have another reward. So this is the hotel data. And the question is that I have checked in yesterday evening, what time is my checkout? Can you find the date? Yeah, exactly, thanks. So it's pretty, yeah. And how about the room number?
Probably,
114. Yeah. So this hotel stores the data in a very simple way, this hotel system. And I have managed to create a Mastercard that unlocks all the doors in a given hotel. Actually, in all the hotels that use it. And it takes me about a minute if I just have a guest card for this. But I'm sorry, I can't tell you exactly how I did it because the vendor doesn't plan to patch it. So it will have to remain a mystery. Well, maybe I will just give you a short video. It was one of the hotels that uses it. It was a 4-star hotel. I won't tell you where. So I just created a Mastercard and I just walked and unlocked everything. So it's not as funny as it looks like. It's just boring. But you know. So I'm really sorry, but I couldn't resist this slide. Well, of course, my hack wasn't even remotely close to the original ones. But well, I just couldn't resist, and I just had to put this slide. By the way, this vendor has a website, and on its website, it has a list of all the hotels that implement the system. So you can browse by the country, and you can browse by the hotel name, and so on. There are lots of pictures. There are, in most cases, very luxury hotels. And I'm sorry, I won't give it to you either. You will have to believe me that this is true. And I suppose not a lot of you know that you can create some kind of special card that's called crime scene card. So it locks the door permanently, and you cannot open it even if you have a Mastercard. So the door needs to be forced open, and police needs to break it. So I'm sorry, I won't give it to you either. But what's actually real risk with it? Well, you might argue that some hotels still use such cards, like this plastic with just printed small dots. We've seen this in real life like 2 weeks ago. We use much less secure keys in our doors every day. Of course, there's monitoring guards and so on. So what's the problem? Well, of course, it depends. If you didn't hear this, I recommend to reading it. It's a great story of a hotel hacker by Andy Greenberg that used just the DEF CON published information about how to break special hotel locks, and he was just driving several years and stealing everything from towels to TVs. And another story about assassination of one of Hamas leaders was also related to hacking hotel door locks. Enough for hotels. If you are interested in city cards, there is a recent mobile application that just reads the card data and decodes it, how much has left and so on. It's not intended to be used as editing the data, but you can see how the guy reversed the thing. He just took several trips and just compared the diffs of the binary. And some vendors used very simple ways, the static keys and so on. So even in Poland in 2013, it was already a mobile application that, of course, if you have the keys, you can use just simple mobile application to access the data. And they figured out how to decode it and clone it. And recently, also, another guy was sentenced for claiming money back from Oyster cards. But it took 7 years for Oyster cards to switch to a different system. Mobile access is just a simple, quick preview of my recent research. Well, everyone knows and I think agrees that we are going mobile, so access control systems also are going mobile. So we have access control systems that unlock the door using NFC in your phone. It works similarly to mobile contactless payments, uses the same technology. I spoke about it in last year, if you're interested in security of this technology. And there are rumors that it will be soon available also in iOS. We'll see. In most cases, of the systems that I have checked, it's just a new mobile application that works as a card. So it connects to this reader, and in many cases, we still have this WGAN thing in the backend. The mobile application just stores the key that is specific to the reader, and this UID that is based, this user-specific UID. So what could possibly go wrong in such system? Well, of course, malware, for example, could steal the card data from your phone. But there is another risk. A malicious user that has full control over his phone, he could manipulate this card data, this UID stored in his phone, and try to get access to other restricted areas. And it was actually the thing that I managed to do in one of the systems. There is also another attack. A malicious user could get administrative access to the reader also. It's just they often use the same keys, but just a different content. So I will probably publish some more info about it soon. And I think many vendors are just missing a new opportunity to make it right. So we could create an end-to-end encryption from mobile phone to the backend if we just exchange the backend, and individual keys that are mutually authenticated. And I've seen just one single system that works like this. So, by the way, it's not really easy to get such system, not only because you have lots of, it takes usually like 1,000 UIDs and multiple readers to buy, but also if you try to ask for this, to get it for testing, the vendors get suspicious. So from one vendor, I got this email. Well, maybe I shouldn't have emailed him from smartlockpicking.com. but I'm really glad that he was so honest, because it allowed us to cooperate further, actually. I guess we're just running out of time. For the end, I'll just finish with some risk considerations. Like we measure the risk by the impact times probability or ease of exploitation. And in the beginning, probably it was very difficult to exploit such systems. Like you needed to have this Proxmark, which was way more expensive at the beginning. No one knew how to do it. But with time, the conditions to exploit just are very easier. I think we may have already crossed this thin red line that makes this risk real, in fact. So you should, of course, design the system properly. And I would always repeat that own crypto is a bad idea. Not always the secrecy is a bad idea. In such systems, you can use non-public specification, but this specification, this system should not require the secrecy. So once the specification is public, no one is able to break it still. If you just want to try some of these tricks that I showed you, you can just visit our booth over there near the chill zone. And if you're interested, I'm also providing trainings about it. The next is in Hack in Paris. So, any questions? I will trade it for a good question.
What about longing the range of?
The range.
Yeah.
Well, I had slides for this, but I decided that there was just too much. So, well, regarding the range, well, it's just the physics. So it's like you could. There are scientific research for this. You can read the communication from the reader to the card from like 20 meters, but you cannot read the communication from the card to the reader because it's the reader that has active power. The tag has no power. It's just inducted by the coil of the reader. So the communication from the tag to the reader you can sniff from like max 3 meters, but in practice, actually you can do it in 60 centimeters, and no one, to my knowledge, managed to do it better than just buying a more expensive reader that reads the tags from 60 centimeters and just plugging this special hardware to the back of the reader and turning it into the sniffer. It was actually featured in Mr. Robot, for example. Yeah.
And what if you have 2 antennas? Thank you.
No, it doesn't help. There are more different problems like the quality of the signal, and you could fry the chip if you use too much power and so on. So, in practice, I think it's just the better readers that can access the tag from a distance. Thanks.
Okay, you showed tools to dump MIFARE blocks with data, but the specification of, here.
Oh, sorry.
Yeah.
It's just the light.
But specification of MIFARE brings counters blocks. So
yes,
how many
yes.
of this software, because some of the
yes,
tools like
you can have counters.
or Fook, they can dump those blocks, but these tools for smartphones, they got ability to dump these blocks with the proper content, or are made only for data blocks?
Yeah, well, using blocks that are counters, it's one of the tricks that you can limit a little bit the risk, but it's still possible to reveal them, not using mobile phone, to my knowledge, but...
I was curious that if the software for the smartphones got ability to dump those blocks. Yeah.
I don't think so. I haven't actually researched it very deeply, but the one that I figured, I just did it in a different way, not using smartphone. Yep.
I am very surprised that vendor don't have patching this because it is very luck to have access to many places. And
Can you repeat the question?
maybe it's not a question. Maybe it's my fault. So this is. I'm very surprised that the vendor cannot wants to fix the bug that you find.
Yes. It's a common problem for security researchers to explain your intentions to the vendor. Like, yes, it's very difficult to explain. Like, they just treat you like someone who wants to hold them, and they can't understand your intentions. Like, I don't need to publish it. It's not the. I just want to learn about it, how to fix it. Like, so it's not easy to explain my intentions to the vendor. Like, you're right.
Hi. Only one question. Is it possible to use all the countermeasures and use the NFC proper way so it's secure?
Well.
Is it possible?
Yeah, well, it depends on your risk, your individual risk. Like, if you want to use MyFair, I would suggest you to use this fire. But if you can't do this, well, probably you can do all the tricks and countermeasures to make the attacks much harder. So in order to attack your system, one would need to have this. It's $45 and would need to go to the original reader. And if you would diversify the keys, so he would be able to crack only his own card. So this would probably limit the risk to a level that is good enough for you. I don't know, that depends.
But it's not possible to make it like secure.
Well, nothing is 100% secure. There's no such thing. But we just can do it good enough, like for your case.
Thank you.
I think we don't have enough time, but I will be around at our booth. And if you have any more questions or would like to play with it, just feel free to reach me anytime. So thank you.